Lesson 5.5, multiple angle and product of sum formulas. What you should learn. Basically, we're going to learn about multiple angle formulas, power reducing formulas, half angle formulas, and products of sum formulas. We have the multiple angle identities we talked about before. We have the squared identities. We have the half angle identities, and we have the product identities. We're going to do a lot of them today. Now, the first one we're going to start off with double angle formulas. It's probably the most important. It's one you see the most in pre-calc and calculus. So these are double angle formulas. Sine 2u equals 2 sine u cosine u. Cosine 2u has 3 different variants, and they can all be used at special times. So if you have something that all has sine, you want to use this one. If you have an equation that has all cosines, you want to use this one. And there's also a good time to use cosine minus sine u. And then tan is this one. Tan is the one we probably use the least. And you also derive tan just by using sine and cosine. Let's do an example. So we want to solve this, but we have sine 2x here. So what we're going to do here, since it's sine 2x, and this is a cosine, is we're going to change sine 2x using the double angle formula. Sine 2x is 2 sine x cosine x. 2 cosine stays the same. Then we have to solve this problem. Tell me back to here. I would factor, they both have a 2 cosine. So 2 cosine x. We have 1 plus sine x equals 0. We're going to split 2 cosine x equals 0. 1 plus sine x equals 0. Minus 1. Sine of x equals negative 1. We'll solve that in a bit. Divide by 2. Cosine x equals 0. 0 and negative 1, that's all on the unit circle. This is 1, 0. That's at 0 and 2 pi. 0, 1. That's at pi over 2. Pi, negative 1, 0. And 0, negative 1. That's at 3 pi over 2. So let's start with the cosine. Cosine is x. Sine is y. Where does x equal 0? Here and here. Where does y equal negative 1? That's down here. We actually, those two answers, nothing else. Now, it didn't give us a domain. That means we're going to use the general answer. We're going to go pi over 2 plus 2 pi n. We can also go 3 pi over 2 plus 2 pi n. Remember, if you want a shortcut, you actually only need the top one. Pi over 2 plus pi n will get you all the answers because it's just going to go around and around again. But that's how you solve using multiple angle equation. You say sine 2x, you switch it out, then you solve it like normal. But here's my favorite use of the double angle formula. So they want us to find sine 2 theta, cosine 2 theta, and tan 2 theta, given that cosine equals 5 over 13. And right here, they tell you this is quadrant 4. What we're going to do is just make a triangle in given quadrant. And we're going to use that triangle to solve the solution. They want us to triangle quadrant 4. So Galatoa, so this is 5, this is 13. Hopefully by now you know it's a 5, 12, 13 triangle. This right here will be 12. And it is negative because you're going down. So there's our triangle. They want us to find sine of 2 theta. Sine of 2 theta is 2 sine cosine. Go 2 sine theta cosine theta. Or theta's right here. What sine of this, when they say sine, they mean sine of this triangle. Sine of this triangle is opposite over hypotenuse. This guy is negative 12 over 13. There's still a 2 in front. I'm going to put it over 1 because it's a fraction. And then cosine, you can look at the triangle or you can look at what they gave you. Cosine is 5 over 13. And then you just multiply it all together. Negative 12 times 5 is 60, times 2 is 120. 13 times 13 is 169. And that's our answer. Cosine 2 theta. Now the most common mistake here is that people just see the cosine there, and I get this all the time. They'll give me 2 times 5 over 13. That is wrong. It's not, cosine is 5 over 13, not theta. Theta is not 5 over 13, cosine is. What you're supposed to do is, what's cosine 2 theta? That's a formula. There's lots of them. In this case, I'll use cosine squared minus sine squared. This is the one time I like to use that one. So I'm going to use cosine squared theta minus sine squared theta. And now we can plug stuff in because cosine is 5 over 13. Remember, this right here is the same thing as just cosine theta squared. Right? It's just an easier way to write it. So I could change cosine with 5 over 13 squared. Same thing with sine. We're going to change sine with negative 12 over 13 squared. If we square both of them, we're going to get 25 over 169 minus 144 over 169, which gets us negative 119 over 169. Like that. They also want tan 2 theta. We're running out of space here, but I'll put it right here. Tan 2 theta. Right, so tan, there's a couple ways we could do tan. We could use a formula. 2 tan u over 1 minus tan squared. So we could do 2 tan theta over 1 minus tan squared theta. Or tan is just sine over cosine. I could just do sine over cosine and reduce it. Either way works. I guess I'll use the formula because we have it here. 2 times tan tan would be negative 12 over 15 over 1 minus tan squared, negative 12 over 15 squared. It's over 1. So let's see, that does be a negative 24 over 15 over, this is 1 minus 144 over 225. Common denominator, 25, 225. Yeah, this gets ugly. 81 over 225. So that's going to be negative 24 over 15 times 225 over 81, right? Reciprocal. And multiply it out. That is pretty disgusting. Again, another way to do it, tan is just tan 2, it's just sine 2 over cosine 2 theta. That would be my answer for sine, negative 120 over 169, divided by my answer for cosine, negative 119 over 169. And then that one, it looks ugly, but it's just a lot easier because it's just this divided by the bottom, which means multiplied by reciprocal. And those cancel out, and you just get 120 over 119. That's that one. Now, I said this is my favorite. It is my favorite for sine and cosine. Tan gets a little disgusting, but that's how I do it. You can also use double angle formulas to derive stuff. If I didn't know what sine 3x is, I could use a double angle formula like this. I could make this sine of 2x plus x. I guess really I'm using a sum difference formula, but it works the same. I'm making sine 3x into 2x plus x. And now we see sum difference. It's me sine 2x cosine x plus cosine 2x sine x. And then from here, this is sine x, sine 2x is 2 sine cosine. And there's still the cosine x from there. Cosine 2x, you have 3 possibilities. In this case, I think I'm going to lean toward using 2 cosine minus 1. Because this has a sine already, that had a sine already, and we need some more cosines. I'm going to change this to 2 cosine squared x minus 1. There's still the sine. Then let's distribute. I get plus 2 cosine squared x sine x minus sine. And then this, I got 2 cosines. So I get 2 cosine squared x sine x. These match. I get 4 cosine squared x sine x minus sine. That's as far as you could go. Like that is, I guess we could factor out the sine, but that's pretty much what sine 3x equals is this guy. That's something you could do with the sum difference formula. If I forgot the double angle formula, I would use the sum difference formula for 2x to make it sine of x plus x and go that way. And then you could get the sine 2x formula. Power reducing formulas. Here's some power reducing formulas. We use this to reduce the power of something. So if you have something sine squared and you wanted to make it a basic cosine function, you can. There's power reducing formulas. We're not going to use them as much in this class. Same with half angle formulas. Half angles we will use. They're a little tricky because it's more of like a double angle formula. You have to know the double of the angle to get the half angle. For example, cosine 30 is an angle I know. Well, the 30 is the u. What you could use with this is actually figure out what cosine of 15 is. Because when you plug into the formula, you're going to be using 1 minus cosine of 30. That lets you figure out angles of half things. For example here, we want to find sine of 105. It's going to be sine of u over 2 equals plus or minus 1 minus cosine of u over 2. And the plus minus, this means what quadrant we're in. We'll figure it out afterwards. If we want to find sine of 105, what it really is we want to find the double of this guy. That's what we're going to plug into this formula here. 105 times 2 is 210. So that's what's going to go into here. Is we're going to plug 210 into there. That's going to be square root of 1 minus cosine of 210 over 2. Plus and minus, where's 105? 0, 180. 105 would be over here. This is 90. It's in quadrant 2. Sine is positive in quadrant 2. This is a positive version of this. And then that's pretty much it. We just got to simplify this. Figure out what cosine 210 is. Here's 180. 210 is going to be over here. That is a 30-degree angle. It's negative 1 because you're going down. Negative rad 3 and 2. Cosine SOHCAHTOA is rad 3 over 2. 1 minus radical 3, negative rad 3 over 2, all over 2. And then we can simplify this. That's the same thing as 1 plus rad 3 over 2 over 2. Common denominator. We get square root of 2 plus rad 3 over 2. And after we write this, we're dividing by 2. So remember when you divide, you just multiply by the reciprocal. 2 rad 3 over 2 times 1 over 2, which is 2 rad plus radical 3 over 4. And we actually can simplify that because I know the square root of 4 is 2. We get 2 plus radical 3 all over 2 is what the angle equals. That's what sine of 105 equals is 2 plus radical 3 over 2. We also have product of sum formulas. If you have a product of angles, you could turn them into a sum formulas. We use these a little bit, but not too much. Here's an example of it though. So rewrite this product as a sum or difference. So notice I've been multiplied. We want to write it as a sum or difference. All we got to do is figure out which formula it goes with. We have a cosine and a sine. Cosine, sine is this last one here. That formula is 1/2 sine of u plus v minus sine of u minus v, where this is my u and this is my v. We're just going to substitute it in. 1/2 sine of 5x plus 4x minus sine 5x minus 4x. I get 1/2 sine of 9x minus sine of x. We just turn this product into this difference. And that's, you might need that sometimes in like higher math to be able to do that. And occasionally you could go backwards. You have a sum or a difference and you want to make it into a product. Here's an example. We're going to do that. We're going to find the exact value of cosine 195 plus cosine 105. Again, we just got to find the formula that works. That's this one. This one. The formula is cosine u plus cosine v is 2 cosine u plus v over 2 times cosine u minus v over 2. That's from a sum to a product. All we do is type it in the way we see it. This is equal to, this is going to be my u and my v, 2 cosine of 195 plus 105 divided by 2 cosine of 195 minus 105 divided by 2. So this is going to be 300, 150. We divide 300 by 2. And this is going to be 90, so 45, cosine 45. And that's something we could do. Cosine 45, we all know, rad 2 over 2. If we have to figure out cosine of 150, I'm going to draw it real quick. Here's 0, here's 180. 150 is in here. That's going to be a 30-degree triangle. That's 1 radical 3 and 2. This would be a negative rad 3 because you're going to the left. Cosine would be negative rad 3 over 2. Then we can simplify it. These two cancel. There we go. And we get negative square root of 6 over 2. That's using the sum to product formula. And that's the lesson.